In this video, I'm starting a completely new unit if you have been following along this SAT prep series. We're on the geometry section. This is the last section in the book, or the last major topic in this book that I've been working through in this series, okay? So in this section, we're gonna get some practice on lines, segments, and rays, okay? So what is each of them? First of all, maybe let's define them real quick as a recap, because sometimes the terminology matters, okay? Sometimes they'll say, like line something or segment something, so you need to know how to interpret them and what they are. Okay, a line starts at a certain point and it infinitely extends in both directions, both the left and the right, or both up and down, depends on how the line is oriented. For example, this is a line. You can say this is line AB, which contains actually all the points, but it extends in both directions, both infinitely to the left and infinitely to the right. You can also say line ABCD, so you can just call it with whatever points you want in the line. You do have to go in order though, so actually you could just say line AD as well if you really wanted to. That's totally fine as well. In this example, a segment does not infinitely extend in both directions. There's a start and a stopping point. For example, segment AB, there will be just that. So you can see there's a start and a stop, okay? You can call this segment AB or segment BA, doesn't matter. For segments, the direction doesn't matter, but for rays, it does matter, okay? A ray starts from a point and extends only infinitely in one direction, okay? So for example, if I just say ray B, that's ambiguous or unclear because which way does it extend? To the left or to the right? So this is where the order matters here. You can say ray BA, so you know that it starts at B and extends in the A direction, okay? Or you could say like ray BD, or ray BC even, so it starts at B, goes in this direction, okay? So for rays, the order matters. Lines, not really. Segments, not really either, okay? Now with that, let's begin. There might be some other topics that come up, so I'll address them when they appear in the problem if they do, okay? In the figure above, Q is the midpoint of PR. If PQ is x plus 3, QR is 2x minus 1, what's the length of segment PR? So as always, you should try this first yourself before watching me solve the problem and seeing what the solution is. Okay? Midpoint just means it divides it in half of equal length, two equal lengths. Okay? So PQ is this length, QR is this length. By the way, there's this like segment addition postulate, something like that. If I remember back from my geometry days, I really don't remember the names of a lot of stuff, but I do know that you can add different lengths of segments. So PQ is one length, QR is another length. Just imagine you're taking those two segments, you're putting them right next to each other. So you can take the total length, PR, which is the sum of the two original, okay? And they said that PQ is equal to QR, okay? So PR would be, okay, let me just write it like this first. PQ plus QR, let me go slowly. This is by segment addition, okay? Again, the whole piece is the sum of the two pieces. PQ and QR, if I plug in directly, x plus 3 plus 2x minus 1, what's the value of x though? Okay, that's why they said this first sentence over here. PQ is the midpoint of QR. So as I said, PQ, the length of PQ is the same as the length of QR because Q is the midpoint. It divides it equally in half. So let's do it on the side over here. X plus 3 equals 2x minus 1. This segment is equal to this segment. We can solve for x here. So 4 is equal to x then. Okay. Therefore, now I can plug into here. Or I could be a little smarter. If x is 4, this is 7, 4 plus 3. This is the same length, so it's 14. I don't have to plug into here, but I could double check. Be 4 plus 3 plus 2 times 4 minus 1, which is 7 plus 7, not a surprise. Okay? That's how we solve that one. Hopefully I went slow enough to explain my thought process. On the segment PS above, PR is 12, QS is 16, and QR is 1/3 of PS. What is the length of PS? Okay, so they're giving a lot of random things here, it seems like. Different pieces. And we want the total length, okay? So how can we do this? Well, PS, what did they give us? They give us PR and QS. Okay? So PR and QS, notice you counted QR twice. So I can write this as PR plus QS, PR plus QS, but I double counted QR, so I can minus the QR. Okay? And QR is 1/3 of PS. Okay? So PS is PR plus QS minus 1/3 PS. I can move this 1/3 to the other side. 1/3 PS plus another whole PS, that is 4/3. PS is, what's PR? 12. What's QS? 16. Okay? I can divide by 4 on both sides first. So 1/3 PS is 3 plus 4, which is 7, right? And so PS is 21. Okay? That's how I thought to solve this. Here you can clearly see it's all about segment addition. In the figure above, which of the following are opposite rays? Okay, so here's the trick. Remember I said earlier, rays, the way you notate it, or way you name it, matters. The direction matters. So ray AB, you start from A, you go in the B direction, okay? Opposite rays, by the way, they point in opposite directions. Opposite directions. Ray CD points in the same direction, right? AB pointed this way, CD pointed this way. CA points this way, CD points that way. That seems good. Let's keep that. DA, AD. Okay, they point in different directions. Let's keep that, but there can't be two answers, right? So I'm missing something, but let's continue for now. CA, I know what I'm missing. CA points this way, BD points that way. So we eliminated one just by it pointing in the same direction, okay? Now, opposite rays. So I gave one condition, they have to point in different directions, but they have to have the same starting point as well. Okay, so let's look over one more time. Since I didn't think of that in the first place, but now I realized it because I didn't eliminate all but one choice, right? So I was missing something, that was what I was missing. So let's look again. CA, CD, that starts from the same point. And the he is both C here. But let's look again. DA, AD, different starting points, clearly, right? And CA, BD. Cross that out, different starting points. Answer is B. In the figure above, AB equals 2/3 BC. What is the length of AC? Okay? We're interested in the total length. Okay? So, what can we do here? Well, AC is equal to AB plus BC, right? By segment addition, okay? Now we got to use this piece of information probably. So, AB, let me write it over here. AB, which is x plus 3, equals 2/3 of what's BC, 3x minus 6. Let's distribute this to both terms. So x plus 3 is, the 3's would cancel, so you're left with 2x here. 6 divided by 3 is 2, so it should be minus 4. Okay? So x is equal to what? 7. Okay? So what is AB? It's x plus 3, so 7 plus 3, which is 10, plus, you can either use this or use that. This is BC, so 21 minus 6, that's 15, right? So the answer is 25. Let me check if I did it correctly. Yes. Okay. And so again, at least this problem set looks like a lot of segment addition. Okay. Didn't really have to know too much about lines here, if anything at all. And then here, the key was, what are opposite rays? They have to have the same starting point, and the direction is opposite. They point in opposite directions, completely opposite directions, okay? All right, I'm going to call it apart here.